Alright, today we will be covering lesson 38-2, correlation coefficient. On the very first slide of this particular presentation, you should have seen the learning targets of 1, we're going to calculate correlation, and 2, we're going to distinguish between correlation and causation. Our paragraph here says the calculation of R gives additional information that helps to describe the data. This data set shows price in dollars and quality ratings for 12 different brands of bike helmets. The quality rating is a number from 0 being the worst and 100 being the best that measures various factors such as how well the helmet absorbed the force of an impact, the strength, ventilation of the helmet, and its ease of use. And as you can see, we have this set of data where it talks about the price and it also talks about the quality rating. They also gave us a table here that covers both the quality rating across the x-axis and our price along the y-axis. We're going to be splitting this lesson into 2 separate chunks, and the first chunk contains questions 1, 2, and 3. 1, 2, and 3. The question first asks, how would you describe the relationship between price and quality rating? Price and quality rating. Does it appear to go up? Does it appear to go down? As one increases, does the other decrease? That's what we're looking for here. And if you're looking at this particular data, it seems that the higher the quality rating, the more expensive the price. Notice how it has this like trend. It's not a very strong trend, I get it, but it's got this upward as one increases the other. So that's what we're going to put here. As the quality rating increases, the price of the helmet Now, we're not sure if one causes the other. In my case, it's probably the higher dollar probably has a better quality. But that's just my opinion. But regardless, they are both increasing at the same time. It says make a prediction of what you think the correlation coefficient might be. So now remember your correlation coefficient is the R value. We talked about that R value quite some time in our lesson 38-1 lesson. And we talked about whether it should be a positive or a negative. Recall that we said the closer it is to +1 and the closer it is to -1 means it's almost a perfect straight line. This is clearly not perfect. This is definitely a weak correlation here because the dots aren't forming this tight line in the positive direction. It seems like it's going up, but not this tight line of I can clearly see the line of best fit. Okay? So if I had to take a guess, I know that it's positive because it's an upward. Okay? So we know it's a positive trend because it increases. And I'm going to say it's closer to 0. It's definitely not 0, but it's going to be close to 0. So we'll say about a positive 0. Let's go with 372. All I know is that it's positive or that it increases. And I also know that it is a weak correlation. And that's because the points are not a definite straight line. Okay, let's take a look at question 2. Using a graphing calculator, enter the prices as one list and the quantity ratings as another list. What is the value of the correlation coefficient for these two variables? So let's take a look at this. I'm going to show you how to do it on the graphing calculator. We're going to start by going to Stat and Edit. Stat and Edit. And notice that I already have data in my L1 and L2 categories. So I'm going to clear those out. And all I do is I go up to the top where it says L1, L2, and I press clear and enter, and it'll clear the whole list for me. We don't want to press delete because then it deletes the entire column and it's very hard to get those back. Now, recall that our X coordinate was the quality rating, which is very awkward in comparison to the fact that this, the way they wrote these, because usually you would think your X's would be on the top row, but in this case, they put them on the bottom. So we're going to type in the 65, the 61, and so on in the L1 column. And then I'm going to type in 35, 20, 30, and so on in the L2 column. So I'm going to quickly type those in. So I've got 65, enter, 61, enter, 60, 55, 54, 47, 47, 43, 42, 41, 40, 32. Now recall that it did say we were dealing with 12 different bike helmets. So we should be having 12 data points in there. And see, look, it's looking for my 13th data point. So that means I have all of them in there. Now I'm going to go to the L2 column and I'm going to type in the top row. So we're going to do 35, 20, 30, 40, 50, 23, 30, 18, 40, 28, 20, and 25. And notice that my two columns should match up because I have 12 data points for both the X and the Y, or the L1 and the L2. I'm going to go to VARs, down to Stats, and I'm going to go over to where it says EQ at the top, and go down to option 7 that says R, because that's what my correlation coefficient is labeled as. When I press that and I hit enter again, it's going to give me a value back. Their value came out to be 0.3034. So again, that was 0.3034. Now, if you recall back to my question 1B, I said it was a weak positive, right? About in that same range, weak, and I gave it a positive value. Let's take a look at question number 3, which is at the top of the next page. Question 3 says, how would you interpret the value of the correlation coefficient in the context of this problem? Now remember, they said that the correlation coefficient is 0.3034. So what does that mean to me? Well, positive basically means it's increasing. Means the linear function is increasing. And the value means it is a weak correlation. So it was positive, so that means that it's increasing, and the value was really, really close to zero. So that means it's got a weak correlation. Means it's not moving in a very straight, linear fashion. The points are kind of a little scattered. On to your debriefing question.